Hello friends, I'm Dilsukhnagar, Maths lecturer from my team's academy. So today I will explain a few more questions of January 23 shift 1 and shift 2 from different topics. So this is one question. So this is first question. A equal to Aij 3x3 matrix such that A of 0 1 0 equal to 0 0 1 first equation, A of 4 1 3 equal to 0 1 0, third equation A of 2 1 2 equal to 1 0 0. By using these three equations, find the value of A23. A23 means the elements which is present in second row and third column. So we want to find only one element by using these three equations. So first equation is given. Suppose actually A equal to Aij of 3 cross 3. 3 cross 3 A11, A12, A13. So A21, A22, A23, A31, A32, A33. So this is the matrix. So these are the order of A, order of A, that is present in first point, first column, first row, second column, first row, third column, like that. So this is a given matrix. So here we want to find the A2, 3 element. A2, 3 means only this element. So first element, first equation is, here three equations are given. So 0, 1, 0, 0, 1, 0, that equal to 0, 0, 1. Okay. So A is equal to, what is A? A equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, 0, 1, 0 equal to 0, 0, 1. This is the first equation. Here no need to multiply the complete, okay? Because if you want to find only A23, so only select second row, first column and equate to this. Second row, if you multiply this, A21 into 0 is 0, A22 into 1 is A22, A23 into 0 is 0. So finally we get A22 equal to 0. This is first value, A22 equal to 0. Next, second equation is, so this is second equation, A of 413. A of 413 is equal to 0, 1, 0. By using second equation, find the one equation. A here also same. So just take the second row and first column. So this is second row, this is the first column. So we will get 4A21. 4A21 plus A22. A22 plus 3A23. 3A23. 3A23 is equal to 1. But already we know that A22 equal to 0. 4A21 plus 3A23 equal to 1. That is equation number 1. And another equation is, so third equation. So A of 212 equal to 100. Same second row, first column. 2A21 plus A22. A22 plus 2A23 equal to 0. Again, we know A22 equal to 0. So 2A21 plus 2A23 equal to 0. This is the second equation. Here we want to find A23. Okay, A23. So just solve 1 and 2. Solve 1 and 2 and cancel the A21. Then find A23. So here we want to solve 1 and 2. So just multiply the equation 2 by 2. Okay, by 2. Then make the A21. The coefficients of A21 are equal. 4A21 plus 3A23 equal to 1. Multiply this equation by 2. 4a21 4a21 by 2 4a23 is equal to 0. Then subtract, so we get minus, so therefore, okay, so minus 4a23 equal to 1, so a23 is equal to a23 equal to minus 1. This is the final answer. So next question from matrices. So matrices, three equations are given. So the system of equations: x plus y plus z equal to 6, first equation. Second equation is x plus 2y plus 5z equal to 9. Third equation is x plus 5y plus lambda z equal to mu. These are the three equations. So by using these three equations, so these three equations has no solution if, okay, if find the relation between the lambda and mu, find the value of lambda and mu. Here already we know that suppose the two equations in two variables, suppose a1x plus b1y equal to c1, a2x plus b2y equal to c2. Two equations, the two equations in two variables, two equations has no solution, unique solutions. Here we have different conditions. Suppose unique solution a1 by a2 is not equal to b1 by b2 for unique solution. For unique solution, suppose a1 by a2 equal to b1 by b2 equal to c1 by c2, infinitely many solution. Infinitely many solution. So third condition, a1 by a2 equal to b1 by b2 not equal to c1 by c2, no solution. These are the three conditions for infinitely many solution, unique solution, no solution. But the given equations are not in two variables, that is in three variables. So just convert the given equations into two variables, then apply this condition. That is a simple method, or we can use Cramer's method. So this is easiest method. So the first equation is x plus y plus z equal to 6. This is first equation. Second equation is x plus 2y plus 5z equal to 9. Third equation is x plus 5y plus lambda z equal to mu. These are the three equations. Now convert these three equations into the two variables. So cancel any one value as you wish. So just subtract these two. 2 minus 1. 2 minus 1, subtract these two. That is y plus 4z. Y plus 4z equal to 3. So x gets cancelled, 2y minus 5, y, 5z minus z, 4z, 9 minus 6, that is 3. This is equation number 4. Now 3 minus 2, so just subtract these two equations, we'll get 3 minus 2, x gets cancelled, 5y minus 2y, that is 3y, plus, so subtract these two, lambda minus 5z is equal to mu minus 9. This is equation 5. This is 5 equation. Now we get the two equations in two variables. Now apply the same this condition. A1 by A2 equal to B1 by B2 is not equal to C1 by C2. Now compare these two equations. A1 by A2. A1 by A2. So 1 by 3. A1 by A2 equal to, for no solution, this is the condition, B1 by B2, 4 by lambda minus 5, not equal to C1 by C2, 3 by mu minus 9, like this. Now cross multiply, equate these two, lambda minus 5 is equal to 12. So lambda minus 5 is equal to 12, lambda equal to 70. This is the value of lambda, and find another relation also, mu which is not equal to one particular value, equal first and last, mu minus 9 when cross multiplied is not equal to 9. Okay, cross multiply 1 by 3 is not equal to 3 by mu minus 9. Cross multiply mu minus 9 is not equal to 9. Mu is not equal to 18. This is our required answer. So next question from trigonometry. So actually this is not trigonometry and straight line. So they are both related topic this question. When f of x function is given, f of x is equal to 6 plus 16 cos pi by 3 minus x cos pi by 3 plus x cos x sin 3x cos 6x. If range of f of x equal to alpha comma beta, then the distance of alpha comma beta from this straight line is. So here in this question, first of all, you want to find the range of f of x. So after getting the range, then the distance of from that point to this line. So perpendicular distance. Already we know that perpendicular distance formula is a simple question. So perpendicular distance of px1 y1 to ax plus by plus c equal to 0 is mod of ax1 plus by1 plus c under root a square plus b square. That is the perpendicular distance. So first of all, here we want to find f of x, the range of f of x. So first simplify this question, this form. So here already, so this is actually in the form of cos pi by 3 minus x into cos pi by 3 plus x into cos x. Here already we know that this is standard formula 1 by 4 cos 3x. Cos pi by 3 minus x cos pi by 3 plus x cos x is equal to 1 by 4 cos 3x. So just substitute, we'll get the answer, the simple proof 1 by 4 cos 3x. So here f of x is equal to 6 plus 16 cos pi by 3 minus x cos pi by 3 plus x cos x is equal to 1 by 4 cos 3x, 1 by 4 cos 3x. Next sin 3x cos 6x, sin 3x cos 6x. 4 1s are 4 4s are, that is 6 plus 4 cos 3x sin 3x cos 6x. 6 plus 2 of 2 sin 3x cos 3x cos 6x. 6 plus, this is in the form of 2 sin a cos 2 sin a cos a. 2 sin a cos a formula already we know sin 2a. This is so 2 of f 2 of sin 6x cos 6x. Again this is in the form of 2 sin a cos a, that is sin 2a 12x. So this is the 2 sin a cos a sin 2a sin 2 of 6x. So that is sin 12x. So this is the f of x value. So after simplification of this, so we want to find the range. Okay, we want to find the range alpha comma beta. Actually, the f of x is in the form of a cos x plus b sin x plus c. A cos x. So this is in the form of a cos x plus b sin x plus c form. Here already we know the form minimum value, maximum value, range value. Already we know c minus under root of a square plus b square, c plus under root of a. This is the range. Okay. So here we want to find the range of this function. Here c is equal to 6. C equal to 6, A is equal to 1, okay, B equal to 0, A equal to 1, B equal to 0. So the range, okay, range alpha comma beta equal to C minus 6 minus under root of A square plus B square, that is 1. So C plus under root of a square plus b square. Okay, that is 1 plus 1 plus 0. C minus under root of a square plus b square. C plus under root of a square plus b square. So our required answer is, so that is 6 minus 1, 5 comma 7. This is alpha comma beta, 5 comma 7. So now we want, after getting alpha comma beta, so alpha comma beta, so just to find out, okay, find that, so the distance of, perpendicular distance of alpha comma beta to this straight line, perpendicular distance. You already know the perpendicular distance formula, mod x1. Mod x1, this is a 0.5 comma 7, 5 comma 7. So substitute in that. So mod 15, okay, mod 15. So 3 5s are 15 plus 28 plus 12 by under root a square plus b square. 3 square plus 4 square. 3 square, 3 square, 3 square plus 4 square. That equal to 28 plus 12, that equal to 40 plus 15, that is 55 by under root 9 plus 16, that is 25 5. So we will get, so that equal to 11. So this is our required answer. Option C is true. Next question from permutation combination. This is easy question, permutation combination. Here, so he is asking how many words can be formed using the word daughter, D-A-U-G-H-T-E-R, daughter, such that all vowels are not together. This is the question. All vowels are not together. It's a very simple question. So actually the given word is daughter, D-A-U-G-H-T-E-R. Okay, T-E-R. This is a complete question. So A-E-I-O-U, A-E-I-O-U. These three letters are so vowels. Okay. So here the question is how many words can be formed from the word daughter such that all vowels are not together. All vowels are not together. So here actually so first here, so find the number of arrangement, total number of arrangement from the letter daughter. Here the no letter is repeated, so here total letters are 8 letters are there. So therefore total number of arrangements is equal to 8 factorial, because here we have the 8 letters are there. So 8 factorial. So next find the, so this is the first bit, total number of arrangement. Next find the number of arrangement. So the vowels are come together. So actually our question is what? So vowels are not come together. So first, so I am finding here. So vowels are come together. Okay. So vowels are come together. So come together. So D-A-U-G-H-T-E-R. So these are the three vowels A-U-E. Okay. Remaining are 5 letters. 1, 2, 3, 4, 5. Now vowels are come together. Means already we know this. So assume that this vowel has a, so 3 vowels has a 1 unit. 1 unit plus 5. 1 unit plus 5, that is 6 factorial. 6 factorial, and arrange these three vowels in 3 factorial ways. So here I am assuming 1 unit. Arrange these three vowels are in any place. Okay, the first 3 places are, last 3 places are, middle 3 places. So that's why I am assuming 1 unit plus remaining 5, that is 6 factorial ways, and arrange these three vowels in 3 factorial ways. So the total number of arrangements, so vowels are come together. Is 6 factorial into 3 factorial. Total number of arrangements are 8 factorial. But our question is what? Such that all vowels are not come together. So not come together means total arrangement. So just subtract the vowels are come together from the total arrangement. So what is the total arrangement? 8 factorial minus vowels are come together 6 factorial into 3 factorial. So this is the arrangement of word order. So in which vowels are not come together. This is our required answer. So the next question is from binomial theorem. This was also January 23, 2025 shift 1 question. The coefficient of xi and x square in this expansion 1 plus x to the power of p and 1 minus x to the power of q or 1i minus 2. Then find p square plus q square is equal to. So that in this expansion, find the coefficient of x and x square. Coefficient of x is 1. Coefficient of x square is minus 2. Find the two equations and solve p and q. Then substitute in this, we get the answer. This is a simple question. So first of all, so I want to expand this 1 plus x whole to the power of p, 1 minus x whole to the power of q is equal to. So expansion of 1 plus x whole to the power of n. Expansion nc0, pc0, x to the power of n. X is 1, so don't take that, plus pc1 into x plus pc2 x square up to so on. This is the first expansion. But here the minus symbol is there. So here also say qc0 minus qc1x plus qc2x square up to so on. This is the expansion of these two terms. So pc0 is 1 and pc1 is px plus pc2 is p into p minus 1 by 2x square up to so on. Here just expand up to x square term only, because here we have given only x and x square. No need to expand up to x cube and x to the power of 4 up to infinity. qc0 is 1 qx plus q into q minus 1 by 2x square up to so on. So here the coefficient of x is equal to 1. This is first equation. So now here find the coefficient of x in this multiplication of two terms here. If one is multiplied with this term, we will get the coefficient of x. So 1 is multiplied with minus qx, then the coefficient becomes minus q. Px is multiplied with constant term, then only we will get the coefficient of x plus p. Okay, plus p is equal to 1. This is the first equation. And second equation is coefficient of x square. Coefficient of x square is already given minus 2. Coefficient of x square is minus 2. So if one is multiplied with x square, then only we will get the coefficient of x square. One is multiplied q into q minus 1 by 2. One is multiplied with x square. Next, p is multiplied with x term only, because here this is x term and again x term is multiplied with x. Then only we will get the x square, that is minus pq. X square term is multiplied with constant, then only we will get the x square term. P into p minus 1 by 2 is equal to, so coefficient of x square is minus 2. Okay. So now here convert these two equations. This is second equation. Convert these two equations in one variable, then solve the equation, then we get the answer. Here from this question from this P is equal to 1 plus Q. Convert the complete equation in terms of Q. So from this P is equal to from equation 1 P is equal to 1 plus Q. P is equal to 1 plus Q. So just substitute in place of P. So equation in place of P, Q1 plus Q or Q plus 1, we will get the equation in terms of Q. Then find the Q. After getting the Q, substitute a Q in this side, we will get the P. Then substitute all P, Q values in that equation, then we will get the P square plus Q square. Here, so Q of Q minus 1 by 2 minus P of PQ, that is 1 plus Q, P equal to 1 plus Q plus P is equal to 1 plus Q or Q plus 1. So P minus 1 from this, P minus 1 is equal to Q, P minus 1 equal to Q, equal to minus 2. Now take the LCM. Take the LCM, send 2 on that side, we get the answer. So Q of Q minus 1 minus 2Q of Q plus 1 plus Q of Q plus 1 equal to minus 4. Now, so solve here, we get the answer. So Q square minus Q minus 2Q square minus 2Q plus Q square plus Q equal to minus 4. Here plus Q square minus Q, 2Q square gets cancelled, plus Q minus Q also gets cancelled. Minus 2Q equal to minus 4. Minus 2Q equal to minus 4. Q is equal to 2. If Q equal to 2, substitute Q equal to 2 in this equation. Q equal to 2 in this equation. P equal to 3. Q equal to 2. P equal to 3. But here we want to find P square plus Q square. P square plus Q square. P square plus Q square is equal to 4 plus 9, that equal to 13. So our required answer is D. This is our required answer. Okay. Hello friends, I am Sridhar, Maths lecturer from my team's academy, so Dilsukhnagar. So today I will explain some previous questions. Previous questions is recently. So recently January 22, so 2025. Shift 1, shift 2, some few questions and from few topics. I will explain few questions. So this is the first question. So the coefficient of x to the power of 2012. So 2012 in this expansion. 1 minus x whole to the power of 2008 into 1 plus x square whole to the power of 2007. This is a recent question. January 22 shift 1 question from binomial theorem. So actually we want 1 minus x whole to the power of 2008 into 1 plus x square whole to the power of 2007. So here we want to find the coefficient of x to the power of 2012. Okay. So first of all, so just equate the powers. So first of all, 1 minus x into 1 minus x whole to the power of 2007 into 1 plus x square whole to the power of 2007. Now here, so these are 1 minus x into, so this becomes, so powers are same, so just club the bases here, 1 minus x into 1 plus x square whole to the power of 2007. So this is in the form of a minus b into a square plus ab plus b square, that is equal to 1 minus x into a cube minus b cube whole to the power of 2007. Now here we want to find the coefficient of 2x to the power of 2012. So just write down the general term. Okay, so general term of 1 minus x cube whole to the power of 2007. So this question is completely based on, so general term pr plus 1 in x plus a whole power n, completely based on this question only. So therefore, so here already become the, so 1 minus x into, okay, 1 minus x into, so general term in x minus a whole power n, so minus 1, okay, minus 1 whole to the power of r, NCR, x to the power of n minus r, okay, x to the power of n minus r into a to the power of r. This is the general term. So now 1 minus x into minus 1 whole to the power of r, 2007 CR. 1 to the power of 2007 minus r, that is 1 only. Here we get x to the power of 3r. Okay, x to the power of 3r. So multiply this whole thing with 1. Again we get the same term, that is equal to minus 1 whole to the power of r, 2007 r CR, x to the power of 3r, minus, multiply this whole thing with x, will get minus 1 whole to the power of r, 2007 CR, x to the power of 3r is 1. So this is the thing. So we want to find the coefficient of x to the power of 2012 in this expansion. So I want to simplify this whole thing like this. Now we can find the coefficient of x to the power of 2012. Okay, we can find the easily. So just equate the x power, where x power is what? 3r. Equate 3r to, so 2012, because I want to find the coefficient of 2012. So r is equal to 2012 by 3. So 2012 by 3 is not divisible. So 2012 is not divisible by 3. So therefore, okay, so we get the r value in terms of point values. So the point value does not exist because TR plus 1, the general term, R should be integers. Okay, R should be integers, natural numbers. So that's why this does not exist, because because 2012 is not a multiple of 3. So in the second case, this case, so equate 3r plus 1 equal to 20.